Okay, good evening all of you. Actually, we are going to talk about applications of trigonometry. Before going to talk about applications of trigonometry, let us discuss about the values. Here, specifically, we want the trigonometric values for the angles of 30 degree, 45 degree and 60 degree. So, just let us try to recollect those things which we discussed earlier. Here, already we discussed it earlier also. When this is 30 degree, then we can say it is 1, 2, 3, 2. And if this is 45 degrees, then you can say it is 1, 1, 2, 2. And on the third one is when the angle is 60 degree, then this becomes 2, 3. These three are the major things which we need. Okay, if we know this, like you can solve all the problems related to these applications of trigonometry. Right, now the question is, how do we solve the problems related to this? For this, basically you have to understand certain points. Always we start with the ground, and for representing the ground we draw a horizontal line. Now simply you understand that whenever a person is standing, here the basic principles for drawing the figures, mainly in applications of trigonometry, if you can draw appropriate figure, half the problem is solved. But for doing so, no need for you to become a Picasso, because no need for you to draw any three-dimensional figures. Remember that for trees, buildings, towers, for everything, simply we represent with a vertical line. And where do we draw the vertical line? We know that all these buildings, trees, everything will be on the ground. So whenever you try to draw the figure, the first thing is you have to draw a horizontal line. Okay, this is the first point. Now, right, I will show you. Suppose a person is standing like this. In general, we call him observer. Okay. Then whenever a person is standing like this, he can observe the things like this. Means when he is straight, actually this is horizontal line, and this is any line parallel to this, and this is also considered like a horizontal line. Okay. Now while coming to the position of the observer, here this is the position of the observer. While coming to the observer, there is one more interesting point you have to understand. That is, if the height of observer is not given, height of observer is not known, at that time simply we represent observer. Observer is represented with a point. So whether in the given problem the height of the observer is given or not given, this is more and more crucial. If height is given, we denote him something like this, like a vertical thing. If suppose the height is not given, simply we denote observer with a point like this. Okay, observer means the person who is observing the things. Okay, this is the first point. Second one is, always we represent buildings, towers. Okay, building, maybe a building, tower, tree, everything is denoted with a vertical line. Vertical line means simply we draw a straight line. Of course it must be vertical, means the angle should be 90, and it is always denoted like this. Of course if you want we can give some name like this. Now in this we have to understand that suppose CD is we consider it like a tree. CD is a tree. Then at that time we can observe that this position of C, this is the top of the tree. If it is a tower, then this will become top of the tower. If it is a building, then this is the top of the building. C is the top of the building and D is the foot of the building if CD is a building. Suppose if we are talking or considering this CD like a tower, then C is the top of the tower and D is the foot of the tower. And if it is a tree, then C is the top of the tree, D is the foot of the tree. Okay, like this we consider. Now mainly in this we have to talk about two things. One is angle of elevation and the other one is angle of depression. What do you mean by angle of elevation and what do you mean by angle of depression? Always, as we discussed earlier, the ground is denoted with a horizontal line, okay, and this is the position of the observer. And suppose you are standing on the ground, and if you want to observe anything which is at a certain height, then the position where you are standing, like maybe the top of the tree, top of the building, you are standing on the ground, this is the position of the observer. From here you have to observe the top. So at that time what happens here, clearly you can see this like this, and this is called actually line of sight, and this is your horizontal line. Okay, or a line parallel to the ground. If suppose if you consider the observer like this, suppose he is standing here, then you can see it like this. So that depends upon whether you are considering this as the ground or this as the ground. If the height is given, then we draw the figure like this. If the height is not given, simply we consider this. Okay, now always remember that whenever the line of sight is above the horizontal line, you can see that the line of sight is above the horizontal line, then the angle formed is called angle of elevation. Means in general, angle of elevation is obtained when we are looking at an object which is at a certain height. Okay. On the other hand, suppose we are considering the horizontal ground, and now this is the position of the observer. Now the observer is sitting here. This is the position of the observer. Because he is sitting here, naturally this is the horizontal line. Means, as I said earlier, it is a line which is parallel to the ground. So when he looks straight, he can view that his looks will be straight like this. This will become horizontal line. Now he has to observe. Say here we know that this line is the ground. Okay, this line is the ground. On this ground, somewhere there is some object and he has to observe this object. Okay, now for this what he has to do? He has to look like this. Now actually this is line of sight. Okay, now you observe this is horizontal line and this is line of sight, and clearly you can observe that the line of sight is below the horizontal line. Whenever, means horizontal line or a line parallel to the ground, it is always in such a manner that it is always straight parallel to the ground. Now if you want to look at the things above your eyesight level, then your line of sight will increase, and here that is called angle of elevation. On the other hand, here you have to look downwards, and the angle formed between horizontal line and line of sight is called angle of depression. So you should know the difference between these two. When do we get angle of elevation and when do we get angle of depression? Okay, yes, very good, correct, Akhil, what you said is correct. It is called angle of depression. Okay, fantastic. So when we look at the objects which are existing on the ground and we are at a certain height, like suppose in a building you are standing in the first floor balcony and you are looking at a plant or a bike parked at the ground, then at that time you have to observe it. So at that time the line of sight will be below the horizontal line. So here it will become angle of depression. And here simply we use one logic, because these two are parallel lines and this is like a transversal. This angle is equal to this. It is the concept of alternate interior angles. That's so whatever the angle you get here, the same angle you can observe here. Okay, these are 2 points you have to understand. Next, related to this, one more thing you should know. Suppose we are considering any horizontal ground, and this is the position of the observer, and suppose a building is here. Building or a tree or anything is represented with a vertical line, as we know. Now suppose here if you consider this is the horizontal line and this is the line of sight. This is line of sight. Now what is your observation? This is your angle of elevation. If suppose the observer is moving towards the building or the tree or something, suppose the observer came here. Now what happens to this angle? You observe earlier here this is the angle and now this is the angle. You can see that the angle will increase. So when building or tree or tower, it is stable and the observer is moving towards, then angle increases. And naturally if he moves away from the building, then angle decreases. Okay, means suppose here, okay, if you consider it from here, this is the position of the observer, then the angle will be less. Means here suppose if you consider like x, y and z, so clearly you can see that x is less than y less than z. This value is less. Maybe suppose if it is 20 degrees, then maybe it is like some 35 degrees and this is like 45 degrees, and if you view it further this will be 60 degrees. Like this the angle gradually increases if you move towards the building. Okay, the observer when he is moving towards the building, angle gradually increases. Okay, and if the observer is moving away, then angle gradually decreases. Okay, I hope all of you understood this. The same thing, suppose the observer is stable. Now in this situation the observer is fixed, he is not moving, but suppose some balloon, aeroplane or like helicopter something, suppose it is flying like this. If suppose moving towards the observer is stable now. Now what happens here? Suppose the helicopter is here. If it is coming towards the observer, you can see that, right? Actually if it is here, you can see. It is a quick observation that when the helicopter is at a far off place, the angle is theta 1. Now you see when it comes here, the angle clearly increased. So if the object is moving towards the observer, then the angle increases. If it is moving away, angle decreases. Okay, these are the simple points which we have to understand. If once we understand this, it is very easy for us to go for the things. Once again I repeat, suppose you are considering horizontal line and this is the position of the observer. Now to look at any object which is at a certain height, for looking at the object at a certain height, what to do? We have to observe it like this. This is line of sight and this is horizontal line. Okay, this is line of sight. At that time, here the angle is called angle of elevation. So angle of elevation is, what is angle of elevation means? You can say angle of elevation is an angle formed between horizontal line and line of sight when the line of sight is above the horizontal line. Okay. On the other hand, suppose the same horizontal line, the observer is here and he is observing an object which is at a downward position. Means now suppose this is like a tower or a building and the observer is here. You see, earlier observer is here, now the observer is sitting here and he is observing any object on the ground. Okay, now here you can see that actually he will see something like this straight. If we look straight, it will be like this. So a line parallel to the ground is your horizontal line. Now for observing, looking at this, he has to look like this. So now this will become line of sight. Here clearly you can see that some angle is formed between these two. This is called angle of depression. Okay. If once we understand these two things, it is very easy. So angle of depression is the angle formed between horizontal line and line of sight, where line of sight is below the horizontal line. So whenever we have to look at the objects which are at a certain height or more height, which are at a more height than where we are standing, at that time we have to look at the objects with angle of elevation. Okay, normally I look like this. If I have to look at an object at a certain height, I have to raise like this and I have to see. This is angle of elevation. On the other hand, this is straight, and if I have to look at any object which is at a certain ground, then I have to look like this. So this is angle of depression. So this is horizontal line, angle of elevation, angle of depression. This is the way in which we understand the things. Now let us try to solve some problems related to this so that you can understand these things very easily and quickly. So first let us go for some simple problems where you can do some simple things, right? Now I am considering few problems here so that you can see them. What is the first one? You observe a tower stands vertically on the ground. Okay, right, I hope you can see them. What is the first question given? A tower stands vertically on the ground from a point which is 15 meters away from the foot of the tower. The angle of elevation of the top of the tower is 45 degrees. What is the height of the tower? So first, whenever we have to solve this problem, as we discussed earlier, first we have to draw a suitable figure. Now just we are going for this first question. A tower stands vertically on the ground. Okay, so first you draw, this is the ground and tower stands vertically on the ground. So you have to draw a tower. Tower means simply we draw a vertical line. We have to draw a vertical line here. Okay, the vertical line, and we denote it like this, AB. So AB is the tower. In this, A is the top of the tower, B is the foot of the tower. So what is AB in the figure means? It is tower. And from a point which is 15 meter away from the foot of the tower. So we know that B is the foot of the tower. From this 15 meter away, a point is there. So observer is present here now. Now the first point is you have to see whether we are given height for observer. No. So simply we denote observer with a single point. Now from this point he is observing the top of the tower. What is top of the tower? We have to understand that this is the top of the tower and this is the foot of the tower. From the foot he is at a distance of 15 meters from the ground. Okay, and he is observing the top of the tower with an angle of 45 degree. This 45. What you are asked to find? What is the height of the tower? We know that AB is the tower, so this is what you have to find. Okay, this is what is given. Now how we are going to solve this problem? Right, first thing is whenever we see the figure something like this, we have to understand that in these types of problems you have two things. One is one angle will be given, and out of the three sides you will be given the measurement of one side and one unknown side. So you have to choose a trigonometric ratio which can connect these two. Means one is the known side, means of whose side's value is given, and one is unknown side. Right, first to go for it, simply you observe in terms of this angle. I know that this is opposite side and this, and of course opposite to 90, this is hypotenuse. Out of these three we have to choose any one side. Which trigonometric ratio is to be taken? Means this is the known value, this is unknown value. So I have to select a trigonometric ratio which can connect these two. Of course we know that either tan or cot can be selected, because tan is opposite by adjacent and cot is adjacent by opposite. Any one of them can be taken. Okay, no problem. So we can select tan. So simply we write tan 45 is equal to, what is tan? Opposite by adjacent. Now actually for this here you can draw a small figure. What is that? You just draw like this. In the same manner you draw the figure. This is 45 degree. We know the ratio, it is 1 root 2. Now what is tan 45 means? Here in what way you are taking the ratio, in the same manner here you have to take. Here simply you observe, I am taking AB by BO. Tan means what do you mean by tan? Opposite. What is opposite here? This, but we don't know its value, so it is AB by adjacent is OB, that is 15 is equal to, here I took this side and this side. So now even in this triangle I have to choose this by this. In which two sides I am taking here? The same two sides I have to take here. So it is 1 by 1. Okay, it is as simple as it is. Here whatever the sides I take, in the same manner we have to take. Now go for simply cross multiplication. So AB is equal to 15 meters. What is AB? Height of the tower. So therefore height of the tower, height of the tower is equal to 15 meters. Okay, this is as simple as it is. First, if you understand how to solve these type of problems, you can do them very easily. I hope all of you understood this. Now let us go for one more problem. So already we completed this. Now let us go for the next question. Okay, now what is given here? A tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground by making 30-degree angle with the ground. The distance between the foot of the tree and the top of the tree of the ground is 6 meter. Find the height of the tree before falling down. This is the question. Right. First, let us try to draw a figure for this so that we try to understand this. First, we go for horizontal ground. Now we have to consider a tree. Now you see here what happens here is, how is the tree means initially it is for a certain height. Okay. Now due to storm or something, what happened? AB is the tree. Actually AB is the tree. Because of some storm or something, it was broken at point C. It need not be the midpoint, it can be anywhere. Okay, at point C it was broken and the branch fall on the ground like this. So this is C. Okay, now actually what is happening, this is the tree, somewhere it was broken and it fall down like this. Okay, now you can understand that this part is simply equal to this, because this is the top of the branch which was broken and has fallen like this. Now you observe what is given here. The angle is given 30 degree and the distance between the foot of the tree and the top of the tree on the ground is 6 meter. Here 2 points, 30 degrees angle and 6 meters is given. So this angle is given 30 degree, and observe, because this is fallen down, this is the top of the tree and this top now touching the ground here, and this is the foot of the tree, and this distance is given 6 meter. And find the height of the tree before it was fallen. Okay, how do you find the height of the tree? Height of the tree means you have to find this entire thing. Okay, if you call it like some x and y, you have to find the value of x, you have to find the value of y. Because this is a right angle triangle, it is very easy. If you observe or look at this, you can find it very easily. How can you find? Just you consider the same thing, like, and here the angle is 30 degree. When the angle is 30 degree, the ratio of sides is 1 is to root 3 is to 2. Now here you compare these two triangles. Here if I take this side, this is unknown, this is known. So y by 6, this part by this part I am taking. So in this triangle also you have to take the same, equal to 1 by root 3. And actually what we are taking here, this is opposite, this is adjacent. So if you want, you can call it like tan 30 is equal to opposite by adjacent. Okay, now you simply go for cross multiplication. Root 3y equal to 6. So y is equal to 6 upon root 3. And of course we know that 6 means 2 into 3 by root 3. Root 3 divides 3 root 3 times. That's why you can say it is 2 root 3. So I got this value to be 2 root 3. But what about this x? How do we get x? We know that AC is equal to DC. Means this is x. I have to find this. Again this is known and this is unknown. You observe. This is the known side now and this is the unknown side. And in terms of this angle, you can observe that this is adjacent and this is hypotenuse. So what is the trigonometric ratio you can use? Can you say? What is the trigonometric ratio we can use? Relating hypotenuse to adjacent means you can use either cos or secant. Okay, suppose if you use cos, you can say cos 30 is equal to adjacent by hypotenuse. Right, what is cos 30 here? Adjacent by hypotenuse. Here you see this is adjacent and this is hypotenuse. So adjacent by hypotenuse means root 3 by 2. Here in what way I am taking? Here also I am taking in the same manner, you observe. So it is simply 6 by x. So now what you are supposed to do? Go for cross multiplication. So root 3x is equal to 2 into 6. And just like the previous one, you can write like 12 by root 3, that is 4 into 3 by root 3. If you want, you can cancel this root 3 times. So it is 4 root. Now you see this x I got 4 root 3. What is the height of the tree? Total height is x plus y. So x plus y is equal to, what is x? 4 root 3 plus y is 2 root 3. 4 root 3 plus 2 root 3 is 6 root 3. That's how we can find the height of the tree. If you want further, you can take root 3 is 1.732 and you can find the value. Okay, I hope you understood this. This is a very easy problem. Just you have to understand what is the method you have to adopt. Okay, now let us go for one more problem. Okay, like again we go for this, even we completed this. Now let us go for the third question. A contractor wants to set up a slider for the children to play in the park. He wants to set it up at the height of 2 meters by making an angle of 30 degrees with the ground. What should be the length of the slide? Here, what are the points that you have to observe? Contractor wants to set up a slide for children to play in the park. He wants to set up it at a height of 2 meters and angle is 30 degree with the ground. Okay, now let us see. So here the slider, this is the slider. Okay, now this is your slider and it is arranged at a height of 2 meters. Means this height is given 2 meters. And in the figure, AC is your slider. AC is your slider and it is at a height of 2 meters. And what is the angle? Angle is 30 degree. The angle is given 30 degree. You are asked to find the length of the slider. Now again you see, in this figure if you observe, this is the angle. In terms of this angle, this is opposite and we know that this is hypotenuse. Always we have to choose two things. One is what is the opposite side and what is the known. This is the known value, this is the unknown value. So we have to choose a trigonometric ratio which can connect these two, known and unknown. What is the trigonometric ratio that can connect opposite and hypotenuse? Yeah, you type it in the chart box. Which can connect opposite and hypotenuse. Trigonometric ratio. T ratio connecting opposite and hypotenuse. Yeah. Type your answer in the chart box. What is the trigonometric ratio that can connect opposite and hypotenuse? You can choose trigonometric ratio. Which trigonometric ratio is linked with opposite and hypotenuse? It is either sine or cosecant. Sine is opposite by hypotenuse and cosecant is hypotenuse by opposite. You can choose any one of these two. In general, we select sine. So sine, what is the angle? 30 degree is equal to opposite by hypotenuse. Now for getting this value 30 degrees, what did we do? Simply we consider this triangle. This is your 30 degree. Then it is 1 root 3 2. Now I am taking this and this. So here I have to take these two values. So sine 30 means it is 1 by 2 opposite by hypotenuse. Opposite by hypotenuse is 1 by 2 is equal to, here opposite is 2 by hypotenuse we don't know. That is, you can take like some h or length, so you can take it like some L. Now go for cross multiplication. L is equal to 2 into 2, 4 meters. So that will become the length of the slider. Length of the slider equal to, this is the way in which we can solve this problem easily and quickly. Okay, or otherwise if you remember sine 30 value half directly also you can write, nothing is wrong in it. Or we can remember it like this, and you can compare these two triangles, whatever the two sides you are taking here, the same two sides ratio we have to write even from this. This is the way in which we can solve the problems related to this. Okay, now okay, just we will go for one more problem, and let us go for this. This is the question I am going to discuss now. Length of the shadow of a 15-meter high pole is 5 root 3 meters. See, shadow of 15-meter high pole is 5 root 3 meters. What is the angle of elevation of the sun's rays with the ground at that time? So height of the pole is 15 meter and length of shadow is 5 root 3. What is the angle of elevation of the sun? This is like more and more frequent to see such type of questions. Here, this is the pole, and we know that this horizontal line is the ground and the shadow is formed. Where will the shadow be formed? The shadow is formed on the ground. So if you consider it like this, this is the shadow. Now here you can see that somewhere like the sun will be here like this, and the sun's rays, the sun ray is going like this. Okay, of course we know that all the sun's rays are parallel like this. There are parallel. Okay, right, because it is from the direction of the sun, it will be like. Now here the sun ray, this is the ground. What angle is between these two? This is sun's ray, and this is like two things you need. What is the height of the pole and what is the length of the shadow? From the question you observe, what is the height? This is the height of the pole, 15-meter high pole. This is the height of the pole, and 5 root 3 is the length of the shadow. So 15 and 5 root 3 you write here. This is 15 meter and this is 5 root 3 meter. The shadow is of length 5 root 3 meter, means in this figure BC is 5 root 3 and AB is 15. Now you have to find the angle. Now simply for this we have to go for it like this. Sin theta is equal to, okay, right, wait here actually now just think of it before going to select whether it is sine or tan or cos. In terms of this angle, you can see that this is opposite and this is adjacent. What is the trigonometric ratio that can connect opposite and adjacent? So T ratio connecting opposite and adjacent. What is the trigonometric ratio that you can use? What is the trigonometric ratio that you can use which is connecting opposite and adjacent? Can you say? It is either tan or cot, because tan is opposite by adjacent, cot is adjacent by opposite. You can choose any one of those two. Here, okay, we take tan and the angle is theta is equal to opposite upon adjacent. Yes, you are right. Now, what is opposite here? 15 by adjacent is 5 root 3. Now, 5 divides 15 3 times, 3 by root 3. But we know that 3 is root 3 into root 3 is 3 by root 3. So, I got tan theta is equal to root 3. Now, what is the angle for which tan I get root 3? For which angle? Remember that in this we use only 3 angles, 30 degree, 45 degree, 60 degree. Only for these 3 angles we talk about. No need for us to bother about the other angles. We know that tan 30 degrees is equal to 1 by root 3. So this is not the value which I have here. Then tan 45 degrees. What is the value of tan 45? We know that it is 1. It is not even this value. Then next, tan 60 is equal to root 3. So by this time you understood what is the value which you want. So what is this root 3 is equal to tan 60. Now you compare these two, this and this. Easily you can observe that theta is equal to 60 degrees. So at that moment the sun's rays are making an angle of 60 degrees with the ground. Okay. Yes, Bharat, you are right. It is 60 degree. Okay. This is the way in which we can solve the problems related to this. I hope all of you understood this. Okay. Now, here in all these problems, we have seen only a situation where we are using only one triangle. Now, there are some problems where we have to talk about two different things. Yes, Somesh, you are correct. It is 60 degrees is the required angle. Now, to understand this, let us solve one problems. Right. Suppose it is given like this. On the ground, somewhere there is a temple. AB is a temple. Okay, maybe its height is like 100 meters. There are two persons are on either side of this temple. One is like some P and another is Q. Now you see, till now we discussed about only one observer. Now there are two observers. The first observer P is observing the top of the temple at an angle of 45 degree. And from the other side, the person is observing the top of the temple at an angle of 60 degree. Then find the distance between the observers. Distance between the observers. So what is the position of observers now? Can you say? P and Q are the positions of observers. P is the position of one observer, Q is the position of another observer. So we want this distance. This is what I have to find. So for this, as usual, if you observe this AB, we know that this A is like the top of the temple and this is the foot of the temple. So first observer is at P. So the distance between the first observer and the foot of the temple this I take like some x. This distance is suppose say x. And likewise, the other person is at a distance of y meter. So if I can find this x and y, then I can find the value easily. Now here clearly you can see that there are two right angle triangles. This is one right angle triangle. This is the second right angle triangle. Now in the first right angle triangle, simply you observe in terms of this angle, this is the known side and this is the unknown side. So for this is opposite and this is adjacent. So what is the trigonometric ratio we can use? It is clearly tan. So tan 45 equal to opposite. This is what we are talking about in triangle ABP. The first triangle I am taking. Tan 45 is how much? Opposite by adjacent. So 100 by x. But what is the value of tan 45? Tan 45 means simply you can just consider it like this. This is 45 degree and we know that the ratio is 1:1 root. Here I considered the ratio of opposite by adjacent. So 1 by 1, that is 1. So 1 is equal to 100 by x. Go for cross multiplication. That's so you can observe x is equal to 100. So this observer is at a distance of 100 meters from the foot of the temple. So for this they will give on either side. Either side means one observer is on one side, then the other person is on the other side. Now again you consider this second triangle ABQ. In this triangle, again angle is given and this is known and this is unknown. Again in terms of this angle, this is opposite and this is adjacent. So what is the trigonometric ratio we can use? Tan. So tan 60 is equal to opposite by adjacent. What is the value of tan 60? Again, because it is to the right hand side, you draw the triangle like this. So this is 60. And we know that the ratio is 1:√3:2. So you have to connect these two opposite by adjacent. √3 by 1 equal to divided by y. Go for cross multiply. So √3y equal to 100. So y is equal to divided by root. If you want, you multiply both numerator and denominator. That's how you get 100 √3 by. Now what is the total distance? This is 100 √3 by 3 and this is 100. So distance, total distance is x plus y. So simply you can write distance is equal to 100 plus 100 √3 by 3. Because the denominator is 3, this one also you multiply with 3. So then you get it simply like 300 by 3 plus 300 plus 100 √meters. Okay, that's so we can solve the problems very easily and quickly in this. Okay, now first in this I want to consider this problem. You observe this from the top of a building. So here first thing is you have to consider a horizontal line. Now where is the observer from the top of a building? So there is a building. Building means again we draw a vertical line. This is A, this is B. We know that A is the top of the building and B is the foot of the building. So what is the position of the observer now? The observer is here. From the top of a building, the angle of elevation of the top of a cell tower. So there is another one. This is the cell tower. CD is the cell tower. So now From here, if a person look at the things, it is parallel to the ground. This is the horizontal line. He looks straight. So you can clearly see that it is parallel to the ground. Now because this is 90, this is also 90. Now what is happening here? He observes the top of the cell tower at an angle of 60 degree. So from here he has to observe the top of the tower, cell tower, and because the cell tower is at a certain height, he has to look at it like this. Now this is horizontal line and this is line of sight, and it is above the horizontal line, so this is angle of elevation, and this angle of elevation is given 60 degree. Okay, now from the same point he observed the foot of the cell tower. What is the foot of the cell tower? D is the foot of the cell tower and C is the top of the cell tower. So from the same point, the observer is not changing, he is standing here only. But now from there he has to look at the foot of the tower. Now what is the angle of depression? Remember that this is your horizontal line and earlier this is the line of sight, so this is angle of depression. Now this is the line of sight. Clearly you can see that in the second case the line of sight is below this horizontal line, so this is angle of depression. What is the angle of depression given? 45 degree. So this angle is 45 degree. Now here you have to take two right angle triangles, and further what is given? The distance of the building from the tower. So this is building and this is the tower. AB is building and CD is tower. Okay, the distance between them is given 7 meter. If this is 7 meter, clearly you can see that this is also 7 meter. Okay, then you have to find the height of the building, height of the tower, both you have to find. Now how do we solve this problem? The first and the foremost thing that we can do is, these two are parallel lines and this is a transversal. So if this is 45 degree, this angle will become 45 degree. Now you observe this right angle triangle ABD, right? In triangle ABD, you can see that in terms of this angle, this is opposite and this is adjacent, and this is unknown, this is known. So you call it for the time being like some x, so which is the height of the building. So tan 45 equal to opposite x by adjacent is 7. Now we know that the value of tan 45 is 1. So 1 by 1 is equal to x by 7. Go for cross multiplication, is equal to, that's so you can get the height of the building. Okay, this is 7 meters. Now further you just consider this like some y. This point I am taking like some e, the point I am taking by 7. So this total is the height of the tower. Now again you can see a right angle triangle here. What is that right angle triangle? This is the right angle. In terms of this right angle triangle, this is the angle and this is opposite, this is adjacent. So what is the triangle that we can take here? In triangle AEC, tan 60 is equal to y by 7. But what is the value of tan 60? We know that it is root 3. So root 3 by 1 is equal to y by, go for cross multiplication, y is equal to. Now can we say that this is the height of the building? Means the answer is, so height of the building already we got, this is 7 meter. This is not the height of the cell tower. Observe here, Height of the cell tower is this plus this. You just observe it. This is y and this is 7. So y plus 7 is the height of the cell tower. So for getting the height of the cell tower, what to do? Y plus 7. So height of cell tower, y plus 7. So 7 root 3 plus 7. Here most of the times after reaching this, we will do a mistake. In general, we add these two and we say 14 root 3, which is wrong. Be careful. 7 means it is 7 into 1. You take 7 common. This 7 times of root 3 plus 1. If you take 7 common in these two, here I have root 3 plus 1. Okay. So 7 root 3 plus 7. 7 means 7 into 1. If you take this 7 common, 7 times of root 3 plus 1. Okay. Be a little bit more cautious about this. This is the way in which we can find solution for this. Okay. I hope all of you understood this. Now let us go for one more question. Right, you observe this. Now I am going to discuss this. A statue stands on the top of a 2-meter tall pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60, and from the same point, the angle of elevation of the top of the pedestal is 45 degree. Find the height of the statue. Here you are given two angles, 60 degree and 45 degree, and the height of pedestal is 2 meters. So always, as we discussed several times, uh, drawing appropriate figure is more and more important in these problems. Now you see here, this is the horizontal ground and you name it like something like AB. This is pedestal. What is AB means? AB is pedestal. Okay. On this you have the statue. Now your BC is your statue. Okay. You just try to draw it like a single line so that you only one line get confused. Okay. Now on BC is your statue. As per given data, what is the height of the pedestal? 2 meters. Means from here to here it is 2. And this is what is not known. And now where is the observer? Here somewhere the observer is standing. From here, now you see in AB, A is the foot of the pedestal. A is foot of pedestal and B is top of pedestal. And also B is foot of statue. Here don't get confused. Top of pedestal is foot of statue and C is top of statue. From this point, first he observed the top of the statue and also he observed the top of the pedestal. Clearly you can see that this angle is less and this angle is more. So here you are given two angles 45 and 60. You can see this is 45 degree and this total angle is 60 degree. Now you can see two right angle triangles here. Okay, if you want to solve them, you can draw them like two separate diagrams and you can understand this. The height of the statue is not known. You take it like H. You have to find BC. Now how you are going to solve this? And I don't know, even this side I take it like some X. That is the distance between the observer and the foot of the pedestal. Now just for your quick understanding, I will draw a separate figure for you like this. This is A, this is B, this is O. Means I am taking only this right angle triangle. Now in this pedestal, is 2 meters and this is x and this angle is 45 degree. Now you know in terms of this is opposite and this is adjacent. So what is the trigonometric ratio we have to use? By this time you are very much familiar with this. What is the trigonometric ratio you have to use? Tan. So tan 45 degrees is equal to 2 by. But what is the value of tan 45? It is 1. 1 you can write like 1 by 1. Go for cross multiply. So then you can say x is equal to 2 meters. So this is right. Is it clear? Now, how are we going to do this further? Just observe. What is the other right angle triangle you have to take? This whole thing you have to take. This is the other triangle. Now, we know that this total height is h plus 2. And already we found this is 2. And this total angle is 60 degree. Now, in terms of this, you have to find. And here what can you say? This is opposite, this is adjacent, and we know that the trigonometric ratio connecting these two is tan. So what else? You can write tan 60 is equal to opposite by adjacent. What is tan 60? We know that it is root 3 is equal to h plus 2 by 2. Go for cross multiply. H plus 2 is equal to 2, 3. So h is equal to 2 root 3 plus 2 will become minus 2. Again 2 means 2 into 1. You can take this 2 common in these two. Clearly you can see that this 2 is common. So if you take it common, then what you are going to get? 2 times of root 3, 1. This is the height of the statue. Okay. So therefore height of the statue is equal to 2 times of root 3 minus 1 meters. Okay. This is the way in which we can solve the problems. Okay students, I hope you understood in this